And I'd like to go back to our learning logs, and I'd like to revisit a couple things about y equals mx plus b and about rate of change and slope down at the bottom. So we should have some notes here. If you are absent for that, you might want to leave yourself a little bit of space and borrow notes from your neighbor at some point today. Get these copied down. I just want to remind you, you do have in your packet a couple spots for other notes. So if I add something in here, but you don't have room in your packet, feel free to just turn the page and stick it on the next page. But you're going to want to get this stuff into your notes. Let's start with slope. We've been working a lot with slope triangles. So I want to add a little bit into our notes here about slope triangles. So I am going to insist, you're going to get points for it on our test, that every time you draw a line in this class, if you're graphing a line, that you draw a slope triangle next to your graph. We're going to practice with this in just a second. So when we do a slope triangle, if it's positive, we will draw ourselves, this will be like a little, kind of just a little sketch that we'll put right next to our graph. I want you to draw me a line with an arrow on it that's pointing up and to the right. That's what a positive slope would be, right? If I were walking up this hill, that would be a positive slope. And our slope triangle is going to start at the beginning of that, and it's going to go up and over. So for example, if I had a slope m equals 3/5, you're going to draw that line, you're going to draw that little triangle, and you're going to stick the 3 and the 5 in the right places in that triangle. Now remember, slope is rise over run, so where's the 3 going to go? It's going to go on the up and down part, right? That's our rise. So the 3 is going to go here, and the 5 is going to go there. This is just a little tiny thing that we draw next to our graph. And I know some of you are going to be like, yeah, I really need to draw that. Can I just draw the line? And my answer is yes. If you want full credit, I need you to draw the little slope triangles. Okay. Anybody curious why I'm asking you to do this? Are you willing to trust me on this? Those of you who do this are going to make less mistakes. That's why. Now, once we get done with chapter 2, I won't make you draw these anymore. But for right now, I want everybody to do this every time we draw a line. Okay, what if it's a negative slope? Let's say our slope was something like m equals negative 1/4. Now when I draw my slope triangle, I'm going to draw a line going down to the right. Always goes to the right. And I'll draw my slope triangle off the beginning of that. And this time I'm going to go down and over. What's that? So I'm purposely not drawing it along the grid lines here because I'm going to use these numbers. So I'm not actually counting and making it accurate. So we'll do that when we actually graph it. This is just a sketch to help us think through how am I going to count when I actually get onto the graph paper. So where's the 1 and the 4 going to go? It's rise over run. Rise is the up and down part. Run is the left and right part. So I want to do an example of graphing a line today. And we're going to put this, I'm going to put it up in my learning log up here because I have space. You guys have a pretty decent chunk of space up here. If you do, go ahead and put it there. If you're running out of room because you wrote kind of big, that's fine. Just flip the page. You got lots of extra notes on the second page there. So we're going to do an example of graphing a line. And this is our notes, right? This is what we're going to fall back on if we get stuck on our test. Let's make sure we get some good explanation and not just the final answer. So let's do y equals 1/2 x minus. And I'm going to draw my graph just right off the side. Okay, so I want to make some quick notes here. Sorry, I'll give you a chance to get caught up. I'm moving too fast, I can tell. That -3 is our y-intercept. And I'm going to make myself a little note. When we graph lines, that's where we always start. No, let me get you one. I'm sorry. So -3 is our y-intercept, and that's on the y-axis, labeling my y-axis there. And go ahead and draw a point at -3 on your y-axis. And I like to, I'm a visual type person, so oftentimes I like to have arrows that link things together. The other piece of information that we get out of the equation is the slope. And I'm going to use the slope right now to draw a slope triangle. So let's practice what we just did a second ago. That's a positive slope, agreed? So just off to the side here, I'm going to draw myself a little line with an arrow with a positive slope. I'm not counting or anything. I'm just drawing a rough sketch of an arrow going upwards. And I'm going to draw my slope triangle going up and over on that because it's positive. And I'm going to put that 1 and the 2 in the right spots in that slope triangle. So remember, rise over run. So we're going up 1 and over 2. So, Chris, you're right. This is not accurate. This is like a rough sketch, right? But now I'm going to turn it into the accurate thing. So I'm using this rough sketch to just get an idea. Now we're going to make it accurate. So we'll go back to where we started from, our starting point. And we're going to count up 1 and over 2. I'm just going to kind of make some dash lines. I normally wouldn't draw anything on there, but I think it helps us to see in our notes. I'm counting up 1 and over 2, up 1 and over 2. And just keep counting up 1 and over 2, plus you, until we run off the edge of our graph. Yep, keep going forever and ever and ever to infinity. or approaching infinity. And then when we run off the edge of the graph, we want to back it up and go the opposite direction. So go back to your starting point, and this time count down 1 in the opposite direction 2, and draw a new point. And down 1 and over 2 and draw a new point. And that's as far as I can go. I've run out of graph. Now it's time to connect those lines up. And we've got our line. You know, I just noticed I'm missing something on my notes up above. We haven't written y-intercept up here, have we? Let's go ahead and add that. Some of you might have already put this in here. B is the start value. It's where x is equal to 0, but it is the y-intercept also. Why did it have a what? On this page?
Yes.
I have a what now?
You wrote down an end.
Oh, down here? That is a really bad M, isn't it? Thank you. I should correct that. There is a little. Yeah, I didn't make it a very good M. My apologies. Good eye. Good eye. Okay. You want to leave that out on your desk because you're going to be referring to that today, but let's go on to, this is going to go into our notes, but it's going to go on that graph paper. If I could get you guys to open up your books to page 59 and get your graph paper out, we're going to go ahead and start. We're going to do a couple of these together. And then I'm going to have you working in your groups to finish the rest of them. So we are working on section 2.1.4 today. And again, this is on page, well, the first problem we're going to see is on page 59. This is the line factory. All right, so this is a little cheesy, but that's all right. Sometimes cheesy is good. I want to read through the original problem here. So this is number 37. Again, we're on page 59. And let's do that thing that we've done before where I'll have one person read one sentence and then they'll pick somebody else in the room to read the next sentence. All right, does anybody want to volunteer to go first? You're going to get to pick who reads next if you volunteer to go first. Mary's going to go first. Mary's going to start off with you are. Awesome. You actually did 2 sentences there, above and beyond the Call of Duty. Thank you for that. All right, Mary, who's reading next? This is a short one. You can go 1 or you can go 2 if you want. Don't read more than 2, though. All right, who's next? Fantastic. Who we got up next? Or however. Somebody who hasn't read yet. We're at however. However, if. Okay, next. All right. So, actually, we got one more sentence there. Who's our last person? Okay. So the big idea here is we're at a factory. Factory produces lines. Customers are sending us orders, and we have to determine, can we make a line to match their order? All right. And this last piece is where we're going to start with. The factory standardizes its graphs by scaling the axes from -10 to 10. So this is number 37. So on your graph paper, let's go and write 37. And we're going to start with part A. And part A talks about line A. And the important information that I see in part A is that line A goes through a particular point, 2, 5. So I'm going to say line A goes through 2, 5. Probably could have just written goes through 2, 5, right? Oh well. And let's draw ourselves a graph. Now they said they wanted us to go from -10 to 10. I'm going to modify this, folks. Actually, no, we need to go -10 to 10 for this. So I'm just going to kind of do a little guesswork here. Count down 10. Need to make sure we got at least 10 in both directions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think you guys are probably going to need more graph paper. That's all right. We might need lots more graph paper. Looks like we're probably only going to be able to fit 2 problems on each page. So I'm pretty sure I got at least 10 in all 4 directions here. And let's go ahead and label our X and our Y axes on there. Well, someone's got to make the lines. It's not like lines grow on trees. Lines don't grow on trees. Otherwise, we'd have a line orchard. All right, let's draw this point. We got to draw a line that goes through 2, 5. So keep in mind that's an X and a Y. So a lot of times people learn rise over run, and then they think that's the way points work too. But it's kind of backwards for points, right? We go 2 in the X direction and then 5 up. So slope's different from coordinates. When we have an XY coordinate, it's not rise over run, it's X and Y. So your 2, 5 should be right there. So we need to make a line that's going to go through that point. Can you tell me what line they're asking us for? Or do you think there's more than one that would work for this one? They said in the instructions that it's possible for there to be more than one line. What do you think? Is there more than one line that could go through that point? I think there's lots of lines that could go through that point, right? So let's draw a couple. That's against an infinite number, you think?
Yep.
So if you've got a ruler, or you can just use the edge of your book or something, I'm going to draw a line that goes through that point, and I'm going to have to write the equation for this line. So I want to make sure that any lines that I draw have nice, good y-intercepts. So I'm going to pick a point, I don't know, maybe like right here. And I'm going to draw a line through that point. Can you guys do the same thing? Can you make me a line? I chose to have a y-intercept of +2. So make a line that's going to go through that point. It's also going to go through +2 on the y-axis. Someone give me a number between 5 and 10. Between 5 and 10. 7. A couple people said 3. That's hilarious. 7. Okay, draw me another line that has a y-intercept at 7 that also goes through that same point. So I think we have already run into a situation where the customer ordered something. We were like, sorry, buddy, I can't make you this because there's 2 different options. And I think you'll probably agree, as Chris said a second ago, there's more than 2 options, right? How many different lines could we draw that go through that point? I'd say we can do an infinite number of them, right? But we've shown the customer, okay, we got at least 2. Now, part of our job is not only to draw the lines, but to write equations for them. Okay, so let's write an equation for this first one that we drew. It's going to be y equals. We want to make a slope triangle someplace on this line. So I need to pick a couple good points. I'm going to use this point here, and I'm going to use this point up here. That looks like a good point. Make myself a little slope triangle here. What are you seeing for our slope for that line? First of all, is that a positive slope or a negative slope, this line? It's positive. If I walk from left to right, I'd be going uphill. I agree. And our rise over run is, it looks like it's up 3 and over 2, agreed? So 3 over 2 is our slope. Don't forget your x. We always have x after the slope. And then I'm missing something. I gotta have plus something at the end. Plus what? Plus 2, because that's where it crosses the y-axis. So 3 over 2x plus 2. We can go back to our customer and say, is this the line you want? Y equals 3 over 2x plus 2? Or is this the line you want? See if you can write an equation for this one for me. So for this one, slope triangle for this one, I've got lots of different points I can pick. I'm gonna go this one. Looks like I can go down 1 over 1 for this one, the way I drew it. Is that a positive or negative slope? If I walk this line, I would be walking downhill from left to right. So that's a negative slope. We got 1 over 1. Don't forget your x. X always comes after the slope. And then we just need a y-intercept for this line. What's our y-intercept? 7, so plus 7. You guys get the idea of what we're going to be doing? Yep. So I'm going to have you working in your groups here in a minute. And basically, you need to take the information that they gave you and you need to draw a line. If it's possible to have more than 1 line, then give me 2. You don't have to draw every single possible line, which is good because it would be impossible to draw all of them for this page. We'd be here all day and then some. But if it's possible to draw 1 single line, just draw that line. You need to write an equation for each of your lines. Questions? Yeah, we're going to put them on different graphs. So you're going to probably need more graph paper because we got 7 problems. It's probably going to take you, you're probably only going to be able to fit 2 graphs on each piece of graph paper because it's not printed on the back. So I'll put a big stack of graph paper up here and you can come up and grab as you need it. Question. I want everybody in the group to draw each one of them. That's a great question. Thank you for that. I want everybody in the group. So we're not going to divide and conquer today. Okay, I want everybody in the group working on the same problem at the same time. And we're going to just start on line B and keep going from there. You're probably not going to get all the way up through line G. I bet most groups aren't going to get up to, because I'm going to stop you in about 20 minutes or so. Because I want to give you some time for homework at the end. Okay. So I'm going to guess that most people, I'd like you to make it a goal to at least get up through E. Some of you might finish all of it. All right. Questions, comments, concerns? All right, you guys know what to do next. Get into your groups, turn those tables, make sure they're right up against each other. If you got 4 books at your table, if you would like to put 2 of them away or 3 of them away to get some stuff off your table, I'm okay with that. Expectation right now, folks, is that everybody in the group is working on this same problem. Help each other out, ask each other questions, get my attention if I can help you as well. Hector, can you make that phone invisible for me, please? Thank you.